In this video, we will look at the revision exercise 11. You will find this on page 515 in the Namibian AS-Level Mathematics textbook, Y equals mx plus c to success. Let's look at this exercise. And again, I'm going to break it in two parts. So 1, 2, and 3 I will do in the first video, and 4 and 5 in the second video. Okay, let's start. By differentiating 1 over cos theta, show that if y equals sec theta, which is actually the same, then dy over d theta is sec theta tan theta. Now, I want to take you, and you can, this is very important, and I'm going to show you documents, and it's on page 488. Now, just to find that page, let's just see, 488. Okay, I think this is the page. There I did that for you, and I'm just going to give you the clue. So it's good that you memorize this also, but rather memorize the method. So what we do with this cosec, sec, cot is we are writing it as a fraction, and then we use the quotient rule. So for this one, it was 1 over sin. This is 1 over cos, and when you come to cot, don't make it 1 over tan, make it cos x over sin x, and then you work it out. Okay, so I just wanted to give you that clue so that it's done there, but we're going to do it now. Okay, let's just find the page again. Let's just move it up. Let's just do it. So remember, you can go and you can check on page 488. I also did that. Okay. So let's start. Let's start by saying y is equal to sec theta. Okay, and that is actually 1, and that's the clue they gave you, cos theta. And now I'm going to use the quotient rule. Now, how do I do that? I'm going to say dy over dx. Okay, now what is the quotient rule? Now, the quotient rule works like that. I rewrite the denominator and I differentiate. Okay, make it to d theta, the numerator. Okay, and then I subtract and I rewrite the numerator and I differentiate the denominator. And then I put it over, I take the denominator and I square it. Okay. And then, okay, now this is very important. This is cos theta. Let's just work it out. But remember, and this is actually as soon as you differentiate 1, what do you get? You get a 0. So don't forget that. Minus, okay. There's the 1, and then cos, what if I differentiate that? It's just going to be negative sin theta. And that is going to be cos square theta. Now, as soon as you multiply with 0, it's 0. Okay. And a negative times a negative is positive sin theta over cos square theta. Okay, and now I can be led by, they want sec first. So we can write it as 1 over cos theta multiply sin theta over cos theta. And that will be sec theta, and this will then be tan theta. And there. So you can memorize it, or you can just remember I must do the method with the quotient rule, and then you will also get the answer. Okay, that was number 1 for remarks. Let's look at number 2. Okay, number 2. Take another color. The curve has the equation, it's always the most important, is the equation, and to look at the equation and to see, is it different? Oh, it's a division, so it's also the quotient rule. Okay. Find the coordinates of the point on the curve at which the gradient is -4. Gradient, always differentiation. So I'm going to first differentiate. And now, what am I going to do? I'm going to rewrite the denominator, differentiate the numerator. And then subtract, I rewrite the numerator and I differentiate the denominator. And then I square the denominator. Okay. So if I start with that, it's going to be x minus 5. And if I differentiate this is just going to be 3 minus, and this is going to be 3x plus 1, and this is just going to be 1 over, okay, and I can first leave it like that. I don't think I have to multiply it out, not necessary. Okay, so if I multiply this out, I will get 3x minus 15 minus 3x minus 1 over x minus 5 squared. So I cancel, and it's negative 16 over x minus 5 squared. Okay, so now I go on. I say when the gradient is -4, then dy over dx is -4. So I put in the place of dy dx, remember this is dy over dx, in that place I put -4. Negative 16 over x minus 4. Get that value of x. Okay. So basically, put this over 1, and then I -4 x minus 5 squared equals -16. I divide by -4, divide by -4. So x minus 5 squared is equal to 4. Okay. And now I'm going to simplify this. Now I must multiply out. So I'm doing the short. So it's x squared, multiply with each other, multiply by 2. So negative 10x. And negative 5, so plus 25. Minus that 4. And that is equal to 0. So it's x squared minus 10x plus 21. Equal to 0. Okay, and then 7 times 3, 1 and 1, so it's in group A. So 7 plus 3 is 10, and the signs are the same, negative, negative, x, x. So if I move it up, I'm going to get x minus 7, x minus 3, and that's equal 0. So therefore, x is equal to 7 or x is equal to 3. Okay, but now let's go to the question always back at this point. Now it asks the coordinates. Find the coordinates of the stationary, find the coordinates of the points on the curve at which, so points, and it actually shows you these two. So I'm just going to substitute now in the place of y. Let's just get our y. Okay, so there is in my original, there, do you see? Okay, so let's just do that for that 2 to get my 2 points. So I'm going to keep 2 yellow. So y is equal to 3, and now x is 7 plus 1 and it's going to be 7 minus 5. Okay, so this is going to be 21 plus 1, and this is 7 minus 5 is 2. So it's going to be 11. Or y is equal to 3, put in the 3, plus 1 over 3 minus 5. And that's 9. 9 plus 1 over negative 2. That's 10 divide negative 2. That's negative 5. So I end up nice by saying the whole or the pen is not nice there. The coordinate points are 7 and 11, or 3 and negative 5. And that's how you do number 2. So that was just making use of the quotient rule and gradient and finding the coordinate points. Right, let's do the last one for this video. I'll have to make space. Okay. Okay, here it is. Full space. Okay, let's do number 3. Let's move it up and move it up. It will still be good if you stop the video or that you do the first 3 and then check if you are correct. Okay. Oh, do stop, doesn't matter. Okay, the curve, and I always like to write it down, and now it's an e function, okay, so it's going to be 2x minus, no, it's 3x minus 1. It's just a bit small, I cannot see there, but 3x minus 1 over 2x has one stationary point. Find the coordinates of this stationary point. Okay, stationary points dy over dx is equal to 0. But before I do anything, I have to differentiate. And this is the quotient rule again. And remembering e. So dy over dx is going to be, okay, I rewrite the denominator and I differentiate the numerator. Then I'm going to rewrite the numerator and I differentiate the denominator. And then I square the denominator. Okay. So in this case, I'm going to get 2x, and if I multiply, it's going to be 3e, and it's 3x minus 1. Okay. Minus, oh, I don't like the pen doing that. Just get it correct. 3x minus 1. Okay. Then I rewrite this one. And I differentiate this one, and it's just 2. I like to put it actually in brackets. And then I can square this one, so it's going to be 4x squared. And if I simplify this, this is going to be 6x e 3x minus 1 minus 2e 3x minus 1. That's going to be over 4x squared. Okay. Now, I can first leave it like this. I can now take out something and cancel, so just leave it like this. Now I'm going to go on, and I'm going to say, at the stationary point, dy over dx is equal to 0. So I'm going to go on and I'm going to say, in the place of this dy over dx, I put 0. Okay, and then it's 6x e 3x minus 1 minus 2e 3x minus 1 over 4x squared. Now remember, this is over 1. So I cross multiply. And if I cross multiply this numerator, and I just reflect it to other videos. Remember the stationary points. Say, for example, you are having a graph. Okay, I really don't like draw an axis. It's not. Okay, can I show you here? Okay, there's the graph. Okay, say, for example, this is the graph. This is the graph. I have to put my pen correct. Doesn't matter. Okay. Now, remember, if I'm saying for this a stationary, now let's make the graph a little bit more that it's having a stationary point. Okay, so the stationary point is there, the turning point. Now on the turning point, if you're going to do, it's always going to be, I just want to redraw it. It's always going to be that is the gradient. On the stationary point, on the turning point. And it's always going to be a line parallel to your what? To your x-axis. Okay, and if you can remember a previous video, I said if it's parallel to the x-axis, then it's actually just the numerator equals 0. If it's parallel to the y-axis, it's the denominator equals 0. Okay, but it also works out if you just put the 0 over 1. But I just wanted to connect. The more you can connect the maths, the more you understand and the easier it is to conquer it. Okay, so in this case, it's going to be e 3x minus 1 minus 2e 3x minus 1, and that's 0. Okay, now let's take, we see this is exactly the same. So take it out as a common factor. So it's 6x minus 2. Okay, I could have actually taken out 2, but I'm first going to leave. Otherwise, it's a bit more. I could have taken out 2 also. Doesn't matter. So I divide by 3x minus 1. I divide by e 3x minus 1. Okay, what happens now? Old things. Okay, so I'm ending up with 6x minus 2 is equal to 0. So 6x equals 2. So therefore, x equals 2 over 6, which is 1 over 3. Right. Now, substitute this 1 over 3 in the original equation. Okay, so substitute x equals 1 over 3 in the original equation to get y. Okay, it's not necessary that you write it. I could have just said. Okay, now what is my original equation? Can you remember? I'm first going to write it down, or I can just do it. It was y is equal to e 3, and in the place of x, I put a third minus 1, and then 2x, but 2 a third. And that is going to be e, and it's 1 minus 1, and that is 2/3. And that's e to the power of 0, multiply 3 over 2, but that's 1. Do you agree? So it's 1 multiplied 3 over 2, but it's actually just 3 over 2. Okay, it's not 0. Remember, anything to the power of 0 is equal to 1. So I can end by saying, therefore, the coordinate, remember coordinate, not x value only, of the stationary point, it's still a little bit up, is, okay, and now it's easy. It's just that 1/3 and 3/2 or 1.5. Doesn't matter. Okay, we do it.